Hello, everyone, and welcome back. I hope you had a lovely lunch, and we're back in the session to continue our journey on data visualization. So you've done some bits on Matplotlib, and now it is time in this session to actually go through Seaborn, which is another visualization library commonly used with Python. So we began our journey about 3 weeks ago, more than 3 weeks ago, or almost a month ago. We began our journey on the 1st of May, and we started with Python, and we have learned everything of Python, including files, etc. We then moved on to NumPy. We then moved on to Pandas, and we covered various aspects of how to store arrays, how to read data from data frames, how to do basic operations of data, so which is structuring data, presenting it in different ways, etc. We've learned all of that over the last 3 weeks. And today in the morning session, we have learned how to plot our very first charts. So as you saw, Python allows you to quickly plot dashboards. These dashboards in Python are not interactive. So when you want to make interactive dashboards, you can use tools like Tableau and Power BI. And we cover these later in part of the course, which is both Tableau and Power BI covered. You can also create fantastic dashboards which are interactive using R Shiny dashboards, which is R programming, has actually a library called Shiny Dashboards. And we cover Shiny dashboards as well as part of the course. So far, we have been able to take data. We have been able to read data from files. We are still to learn how to read data from databases, and that's covered in the SQL modules. But for now, we can read data in files, and that's how most data scientists work on data with. And once you take this data from files and you put it into the system and you put it into Python, you are now for the first time able to actually do some levels of descriptive analytics, as we call it. So basically you have data and you're plotting this data on graphs, and we call that descriptive analytics. Starting tomorrow, you will have the opportunity to learn machine learning. So when we go to machine learning, we can also do predictive analytics, which is we're not just looking at data that you already have. We are using data that you have to predict how the data will look like in the future. So you want to predict how something will look like by the end of the month. You want to predict how your sales report will look like by end of the quarter. You want to predict how your sales will look like for the end of the year, right? You can use various machine learning models like regression models to carry out these predictions. And in tomorrow's sessions, when we start with machine learning concepts, we will understand all of the baseline concepts, and we will start building upon creating these ML models that will allow you to do prediction. It'll allow you to do classification, clustering, etc. And there are a whole plethora of things that you can do with ML. And we will begin our journey with ML starting tomorrow. So today's day is all about visualization. It's all about doing descriptive analytics, which is take your data, visualize in various forms. Let's start making sense of the data. From tomorrow, you can actually start predicting what the data will look like in the future. So don't just plot the chart, but predict what the chart will look like, and then plot the predictions on the same graphs. So let's get back and resume with the session. And we will complete the Seaborn session a little 15 minutes earlier than planned. And in the last bit of the session, our idea is to give you an overview of how a machine learning program looks like. So for the first time ever today, just before we close for the day, you will have an opportunity to take a look, a sneak peek at a machine learning program. And this machine learning program is an output of BlobCity's AutoML service. Our AutoML is currently in private beta. It's offered to individuals. If you apply on our website, you can apply for the private beta, and we are able to give you an access to AutoML. So we will show you some output from AutoML on how a machine learning program actually looks like, and you will get a sense of how really simple machine learning programs are. So let's continue once again with the session. And Ashish, I forgot to mention last time, I was going to ask you to give everyone a bit about your profile, like share your experience, share your past work with them. So maybe you can do that right now when you begin the session. Maybe just start with a little bit about yourself and give them an overview of what you've done so far, and that's it. And then let's resume with Seaborn session. Yeah. So Ashish, over to you.
Yeah, thank you. Hey, hi, hello everyone. Yeah, hi, very good afternoon to all of you. So I'm working as a data science, IoT, and computer visions trainer and consultant. So as a consultant, I'm associated with the multiple industries and designing solutions for them. And also, I also work with the Tata Communications and Mindtree Limited. And for as a consultant, during period. So I closely work with their development teams, AI engineers, to design solutions using analytics, using Azure cognitive services, using deep learning and computer vision approach. As a trainer, I have delivered many trainings on data science, um, then again, advanced machine learning or computer vision algorithm, natural language technique, or Industry 4.2 in India and overseas, like Middle East and African, most of African countries. So over there, I have deliver offline and online trainings uh, on these topics. So mostly as a data science, I look at data science as a to design some solution for industry, and for many last 8 years, uh, I'm closely working with the many development teams of in these industries like NTPC and NTPC, Mindtree, Tata Communication, and some more different overseas industries. For them, I have designed some solutions using statistics and data visualizations, machine learning algorithm, and even I'm also helping industry to deploy machine learning model or productization of machine learning model. Okay, using Docker, using Kubernetes and cloud services. So, so I'm in field of data science and AI, machine learning and IoT field. Yeah, so there's something a sort uh, about myself, so introduction about myself. So yeah, so all of you. So during session, if you have any questions, so any general questions related to the machine learning, data science, analytics, you can just you can just let me know so we can discuss, or you can send your query. We can discuss on that. Yeah. And so far we discussed about, let me continue this part here. And so far we discussed about data visualization. Yeah, like we just explore like different function of the matplotlib and some couple of function of the Seaborn library also, like how to use a scatter, how to use like how to use a scatter, count plot, or swarm plot, point plot to analyze any categorical and continuous variable. We will discuss some more different function of the Seaborn library and use Seaborn and Matplotlib library to perform data analysis. Okay, so let's continue with some example, and we'll also talk about that how to plan or how to design some strategy to analyze any data or to design end-to-end data-driven solution. So let's continue with this particular part. So here, I have one. Well, let me open this new notebook. Use it. So the first will import all required library like a pandas, numpy, matplotlib, and seaborn. So import matplotlib.pyplot as PLT, import Seaborn as SNS, import pandas. So we can import all these, first import all these required library. Yeah, pandas, matplotlib, and Seaborn. So the first how to, let me start. First, let's discuss that how to analyze any data or the strategy for it. So I'll just take one. So whenever you're working with any projects, okay, or any business data set, first and very important step is understand business problem. Even from the last 8 years, I'm in this field, analytics field. I'm using a different tools also like a Power BI, Tableau, Access, and even Python's programming to perform analysis and to design end-to-end data-driven solution using machine learning and advanced computer vision algorithm. So the first and very important step is understand client requirement, set end objective, understand business problem, data exploration is very, very important. Even as a data scientist, sometimes we also schedule many, senior data scientists, sometimes we also schedule many meetings with client only to understand business problem and relate with data or information. Sometimes we also schedule some meetings or with domain expert persons. So let's suppose that you're working in, healthcare sector. Some of the your project is related to the healthcare sector, but you're not familiar with all the terms that we use into the healthcare or domain, or you're not familiar with the data. So sometimes we also ask to SME to explain the particular data, or we also take some help from the domain expert person or subject matter expert or client to understand business problem, to understand data and relate with business problem. And then we design strategy, and then we use that particular strategy and using a tool like a Python and a different powerful library like a particular pandas, NumPy, Matplotlib, Seaborn, scikit-learn, TensorFlow, Keras, Spacy, NLTK, many different libraries. We use it to implement it or to design end-to-end data-driven solution. So it's very important. First step is very, very important to understand business problem. Okay, it's very important to understand or to set an objective. Okay, and then data understanding. Okay, and then we start, we work on particular data. So let me give you an example here. Let's understand through some example. You see, nowadays industries are using machine learning and AI into very different way. Most of industry, they are also using AI and machine learning algorithm to automate their operations or to make better decisions. Also, they're using it. So similar way, there's one in the service industry, and they want to automate, they want to automate the some of their operations, like their service desk. As of now, all the customers of the company, they are, directly contacting to the companies or executives and solving their particular problem or asking for some help to resolve the problems. Now, company want to, automate this operation, but at the same time, they also want to improve customer experience. So they're planning to use AI-based chatbot. So chatbot will directly interact with the client, understand the client requirement using NLP technique, and solve it accordingly. So using this approach, they can automate the operation. But at the same time, so you see, without the chatbot or before to the chatbot, average time to solve customer query is 5 minutes. But they want to implement or bring this technology, but at the same time, they also want to reduce this time and make it the 3 minutes. So this is the end objective and goal. First, we'll design the software and automate operation. But let's suppose that when you're designing or using the chatbot applications, now average time is also 5 minutes. So the maybe, if in the business perspective, it's not very useful, or the, this is not an objective. We are not getting the, still we supposed, you're supposed to improve your model to get the end objective or end goal. So again, as a data scientist, as a machine learning engineer, we work on particular solution and improve it in order to get the end objective and goal. Like we want to make it like at least around to the 3 minutes. So it's very important in the starting, first understand business problem, what you're supposed to perform, what is your end objective, and data that you have. Data understanding is very, very important. So in domain knowledge is very important, and that's why nowadays everyone, like in the field of manufacturing industry, retail, e-commerce, all the particular experts from all these domains nowadays learning data science and artificial intelligence, because they want to, they want to implement such kind of solutions in their industries, or automate the operations, or they want to improve customer experience, or they want to many different operations, they want to make a better decisions, and they're using AI and becoming AI expert in the particular field or domain. So the first and very important step is domain knowledge, or data understanding, business understanding, and again the particular setting. It's very important to to understand, to get all this information. And then once we have a data, so as a data scientist, we spend lots of time, even we do lots of research also, only to understand data. And then we start with the data cleaning operation, whether like your data is a clean or not, if there's unwanted column, unwanted rows, duplicates, values, outliers. So we use a different approach to perform data cleaning. And now we can use the approach to analysis, to perform data analysis. And there are the two approaches widely used. One is statistics. One is statistic. We can use a statistics like a particular mean, median, mode, kurtosis, skewness, percentile, or a different kind of a testing approach, hypothesis testing, chi-square, ANOVA. That's something, one approach, like a statistic approach. In that, whenever it's not important, to know the formula of the particular kurtosis, skewness, correlation, covariance, or t-test. Important part is because we are going to use a Python to implement it. Here important is how to interpret outcome and relate with the business problem. Let's suppose that you're getting a mean. So how to interpret the mean value, or how to interpret the standard deviation. Interpretation is very important. Even it is not important, you're supposed to perform data analysis using a data visualization approach, and now you're getting handed of graph. But if you're not able to read those particular graph, then it's not useful. It's very important, to make very interactive and useful graph, so that you can extract informations, or you can and design the final report, analytic report. So we'll also discuss that how to design analytic report, and how to use data visualization approach to perform any analysis on that. And then finally we'll discuss that final report. We'll prepare the final report. So now let's import some data set here, everyone, and we will discuss. So far we discussed some couple of function of the matplotlib and also function of the Seaborn library. And now we are going to discuss that how to use this function, or how to use a different type of the graph to perform analysis, and how to use in real time. So here we'll just import data. So data equals to pd dot read underscore csv. Okay, I'll do one thing. I'm just going to use this collab here. I'll perform these operations because there's some dependencies in my system. Okay, so I'll load data set on this platform, this virtual machine. And here, first let's import all required library. And from here, let's import one data set, bank data. So from here, you can copy path of it, and df equals to pd dot read underscore csv. And everyone, you can read this data from here. And here we have df.shape, and the shape is 10,000 cross 14. So everyone, you can see we have a data set of customers of one bank, and for every, and we have information of the 10,000 customers of one of banking industry. And for every customers, we have around 14 type of information, 14 different type of information of each customer. You can see here we have this information here. Now let's discuss about this data set. So the first variable or first column is represent the row number. So it's just a kind of a serial number. Second is column is customer ID. Customer ID, it's is customer ID whenever the person open bank account. Bank also provide unique customer ID. So we have a customer ID also. Surname, it is a last name of customer. Credit score. Credit score is very important information. It's represent the financial credibility of any person. Generally, the credit score always in the range of 300 to the 900. Okay, if the credit score is greater than 750, so it's recognized as a good. Okay, if the credit score is in the range of 750 to the 900, so it's good. It means that person pay their EMI dues loans on time. If the person's credit score is near to 300, it means that person, it's in the term of banking sector, you can say that person is a defaulter. Person don't pay their EMI, clear their dues on the, don't maintain the account balance. Okay, so if the person do not maintain their account balance or don't pay the EMI or the credit card bill on the time, so their credit score will be near to the 300. Then again, we have informations like a geography is represent the particular location of every the customer. Then again, we have a gender detail of all the customer, age of the particular, age of information of the particular every customer. Then again, we have a tenure, and here a tenure represent that from how many year a customer is a client of bank. So let's suppose that from the 5 year the customer is a client of a customer has a bank account, or the customer is the particular customer is a client of bank. Then again, we have informations like a bank balance of every customer. The next variable is a number of product is represent, so you can see it's contain information 1 2 3 4 like that. So it's represent that how many product a particular customer or each customer is using of bank. One means this customer is using only the one product of the bank. Two means a particular customer is using a two product of the bank. Three means a particular customer is using three product of the bank. Maybe one product is related to the insurance, some product is related to the credit card. Okay. Then again, we have a next variable is a hash credit card. It again, it's contain information in the 1 and 0 format. 1 is represent that a customer's has credit card, and 0 means 0 represent that customers don't have a credit card. Okay, or the customers without credit card, and 1 means customer has a credit card. Is active member, again it's contain information in the form of 1 and 0. 1 is represent that customer is active member of bank. 0 is represent that customer is not active member of the bank. If the customer is actually using a bank services, so it is known as active member. If the customer is not actively using a bank services, so we'll say the customer is not active member of bank, or it is represented by the 0. Again, estimated salary. So we have information of estimated salary of all customer. Then again, the last variable existed, which contain information again in the form of 1 and 0 format. 1 represent that customer left bank or closed their account. 0 represent that customer is still client of bank or did not close their account. So all of you, here we have information of the 10,000 customers of the bank. And for every customers, we have information of their credit score. We have information of their customer ID. We have information of their last name, and whether the customers has a credit card or not, customer is actually using bank services or not, the customer bank balance, customer salary, number of the product customer is using, okay, and customer age detail, we have customer gender detail, and from how many year customer is a client of the bank, or we have a particular customers all whether customers still client of the bank or not, or the customers close their account or not. We have all this information, right? So here, business less, and now let's understand business problem. So this is about data exploration. Now let's discuss about business problem. So as we discussed, so there's one industry, banking industry, and from the last couple of the month, lots of the customers of the bank lots of the customers of the banks are closing their account, and all the top managers, CEOs, they are using dashboard to monitor performance. So dashboard is kind of data reporting tool, and over there we can, they use a different KPIs, so like a key performance indicator. For banking industry, for them a KPI, it could be total sales, okay, or the total number of the customers, okay, so sales of their particular some service, and again the total number of the customer. So the graph is moving out into the downward direction, and all the managers, all the particular these policy makers, they're not happy to see such kind of a trend. They want to know that what has happened in the past, why customers are closing their account, which factor influencing such kind of a trend. They want to know that, so that if they have all these answers, so the policy maker can modify the policy, and modify the particular policy or come with a new policy in order to stop such kind of a trend. So as a data scientist, we can ask the company provide us the historical information or the information of the of customer. And now we have information of the 10,000 customers of the bank. And for every customer, so we have information of their last name, we have information of their credit score, okay, and we have information of the customers like their gender, their age, regions, okay, the customer, whether the customer left the bank or not, salary of the customers, bank balance of the customers, from how many year the customer is a client of the bank. We have all these information. And now we are going to use data visualization approach to perform analysis, and then finally we'll design some report and share with the report to the manager. So manager can use those report to get the answers of all business question, and then they can use those information to design new policy, or the policy makers can use those information to design or the modify existing policy. Right. So as we discussed, whenever we have a data, so I hope all of you are good with the business problem and also this data understanding part. So here the end objective is to perform analysis and to get answers of all this business question. Okay, so here okay. So the first step is, because in real time, there may be in your data, there is some loss of missing value. There is some duplicates value. Okay, so the first will perform data cleaning operation. So if there's any unwanted row or the columns or the missing values, so we'll perform it, different operations, and clean this data. So df dot is null dot sum, and it will be written if there's any missing value. So you see all the variables, there's no any missing value in data set. df dot d types. So you can see the data types is also fine, because customer IDs contain information in the form of a numeric. So we have a data, we have information, data type is integer. So one question from Abhishek, how to merge two train to build insights? So I didn't get you, Abhishek. Maybe we can discuss later on. If you means that how to merge the two different data frame which represent the two different operations or two different kind of information, so we can use a pandas functions, okay, and then we can use a data visualization or statistic approach to perform analysis. Okay, So here you can see the data type is also look fine. So if there's any duplicates value, so df equals to, so df dot drop underscore duplicates. So if there's any duplicates row, so it will be drop it. Now we also discussed that if there's any unwanted rows or the column, so we should drop it. So here we want to perform analysis, and with the help of it, managers can extract all the informations like which type of the customers are closing their account, or what has happened in the past, or which factor influences such kind of a trend. As of now, we don't know the bank existing policy, so we cannot get, we cannot get all the informations. But yes, we can perform analysis and design some report and share with the report with the policy maker, and then policy maker can compare all the particular informations with the existing policies and easily get the useful information or get find all business answers of the business question. So here everyone, you can see there's some variable like a row number, customer ID, and surname. So row number is just a serial number. Okay, customer ID is represent the unique ID of every customer, and surname is contain information like a last name of every customer. And customer ID and surname don't have any statistical relation with decision of the customer, whether customer should leave it or not. So it's not possible if the customer, it's usually it's not very, there's no any kind of a logic. If the customers don't like their customer ID, that's why they left the particular bank. If the customers have some specific, because of the customer's last name, they left the particular bank. So you can see here there's a no any logic, there's a no any statistical relationship between customer ID and the particular decision of the customers, whether customers should left it or not. And surname, so row number is just a serial number. Okay, and customer ID and surname don't have any statistical relation with label. So we can drop these information here, we can drop these variable, because this variable don't have any statistical relation with dependent variable. So here we'll do one thing, everyone will just drop this particular information, because as we discussed, first very important step is data cleaning. And if there's any missing value, so we use a different approach to perform data cleaning, or if there's any unwanted rows of the column, so we should drop it. So here, some of the rows are like a row number, customer ID, and surname. All these three variables are not important. So here we'll just define like a df equals to df dot drop, and you can specify these variable here, and access equals to the 1, because we want to drop it from the column. So we define, because it's a 2 dimensions data. So any operation you can perform as a row wise or as a column wise. So this operation we want to perform as a column wise. So here we'll define access equals to 1. If you want to drop perform any operations so row wise, so we'll take it access equals to 0. Now everyone, you can see now we have df dot head. So here we don't have these variable here, row number, customer ID, or the surname. Okay, and now we can perform analysis, we can perform the data analysis. Okay, now the next part is how to start. What should be the approach? What should approach to start any data analysis operation? So the first and very important part is always start with univariate, then bivariate, and then start with the multivariate analysis. Univariate analysis means first analyze all variable present into data individually. You can use a statistic approach, you can use data visualization approach, any approach, but just follow this strategy to complete analysis or to perform analysis. Always start with a univariate analysis, in that pick a particular individual variables for the given data sets and perform analysis on that. Second is bivariate analysis, in that we take a two different variables and we take a two different variable and check a relationship or relationship, dependency, or impact of each variables on impact of the particular variables on another variable, one variable on another variable. Through that we analyze it during a bivariate analysis. Then multivariate analysis. In the multivariate analysis, We try to find the patterns between the multiple variables or check the particular impact of the multiple variables on some or more than two variables, or the two variables or more than two variables on some other variable. So it is something multivariate analysis. So here first we will perform univariate analysis, then bivariate analysis, and then multivariate analysis if required. So let's start with the univariate analysis. During univariate analysis, we'll select all the variables individually and select the particular graph or approach to plot information or to represent the information in the form of the graph, or to then extract hidden informations from it. So how to start it? So in that, what we will do is we'll select the all one by one, all the variables. We select the one by one, all the variables, and then take some kind of Seaborn library or the Matplotlib library to plot informations or to visualize the information in form of graph. So all of you, first and very important step, you can also use this approach, but it's up to you. Okay. Create a particular, the list of all categorical and continuous variable, because selection of the graph is depend on the type of information you have. If you have image data, so in order to visualize it, we will use IAMSO function, not IAMRead function, or not the IAMSO function. We will use only IAMSO function. So selection of the graph is, or selection of the function, it depends on the type of variable. Okay, so here we will create the two different variables or the list of all the two categorical or continuous variable. As you can see, the credit score, it's continuous variable. Geography is a categorical variable. Gender is again a particular categorical variable. Is active member categorical variable. Has credit card categorical variable. So here we have now the two different variable A and the variable B. Variable A is a list of all continuous variable and variable B is a list of all categorical variable. All categorical and continuous variable, right? So now here, all of you, because we know that we discussed in the last lecture, like if you have a continuous variable, so always use the particular a scatter. If you have a continuous variable and single variable, so use histogram. If you have a single variable as a categorical, so you can use a count plot or you can use a particular pie chart. So here we will do one thing, and we want to perform same kind of the plots on the entire variable. So we'll take a for loop here, and so that we don't need to write a code again and again. You can just simply take a for loop and perform the same kind of operation on the entire categorical or continuous variable. So let's take it and let's understand through some example here, like a geography. As we know that here we have information of the 10,000 customers of the bank. And for every customers, we have information of their geography also. So okay, so Now let's suppose that it's a categorical variable and you want to plot information present into this variable. So we can use a count plot or the pie chart. So let's use a count plot here. Okay. So all of you can see that out of the 10,000, almost the 5,000 customers from the France, or the 2,500 customers from the particular Germany and the Spain. So almost the 50% of the bank customers from the France, almost the bank has a 5,000 customers from the France, and the 2,500 customers from the particular approximate from the Spain and Germany. So the same operation we also want to perform on the same operation we want to perform on the gender and as well as other categorical variable. So we'll just use a for loop and perform the same operation or iterate some same operation on the entire variable present into entire variables of present of the entire categorical variable, all categorical variable. So let's take a for loop. So what are the benefits so that we don't need to write the same code again and again, same type of the codes again and again. So we'll just take a for loop here. So for I in, and we know that B is a list of all the particular categorical variable, right? So for I in B, SNS dot count plot, and here just define the x equals to the I and data equals to df. Then plt dot show. So here x equals to the I means because we know the B is a list of all the categorical variable, right? So the first time and for loop is basically iterate over the sequence. So the first time the particular the B value will be the geography, then gender, then hash critica, then is active member, then existed. And in this way for every variable, it will be written the count plot. So you see everyone, we have a count plot here. And now you can run it this diagram, this particular graph. And we have all the information. The first informations represent that on the x-axis we have a geography, y-axis is the particular frequency. It is represent almost the 5,000 customers from the particular 5,000 customers of the particular bank from the France, and the 2,500 customers from the Germany and the space, Germany and the particular Spain. Now the second variable, which is gender and contain information in the form of male and women, and the y-axis is the particular frequency. And as you can see, almost 55% of the bank customers are the particular male and 45% of the bank customers are female. Now here we have a particular hash credit card. Once means zero and one means a particular yes, zero means no. Okay. Almost the particular 70% of the bank customers has a credit card, and almost 30% of the bank customers don't have a credit card. Here we have is active member. Zero means a particular yes, and one means a particular no. So almost the 50% of the bank customer is not active member of the bank. 50% of the bank customer is not active member of the bank. Then again, we have a last variable is existed. So almost 30% of the bank customers left bank and 70% of the bank customers did not left bank. Okay, so here we have all these information here. And now we have a lot of information about the particular data. So Uni Rate Analysis always help to extract to collect informations present into the data. So Uni Rate Analysis, we can also use it for exploration purpose. So everyone, we have now we have information of all the categorical variable. Almost 30%, 20% of the bank customers left the bank. 55% of the bank customers are male. Okay, and 55% of the bank customers are the male, and 20% of the bank customers left the bank. 49% of the bank customers is 49% of the bank customers or of the around half of the particular bank customer not actively using a bank services. 30% of the bank 70% of the bank customers has a credit card, and almost the 55% of the bank customers are the male, and again the maximum customers from the particular France. Almost 50% of the bank customers from France. And now we'll perform the particular bivariate analysis. So during a bivariate analysis, we check the impact of each variable on the dependent variable. Now we'll take it another variable as a continuous. So here we have a list A. Everyone, you can see now let's print the particular A here. So it should be small a. So it is a list of all continuous variable like your credit score, age, tenure, balance, number of product, or estimated salary. And now whenever you have a particular single variable as a continuous, so always use histogram. So his plot, x-axis, you can define your variable. So for loop, it just iterate over the sequence, and the list is a sequence. So the first time I will be the credit score, second time I will be the age, then tenure, then balance, then number of product, and then estimated salary. So here it's written the particular all the information. So everyone, you can see we have a particular the histogram and for all continuous variable. So the first continuous variable is a credit score. So we have a histogram or the distributions of the credit score for all the 10,000 customers of the bank. And here you can see most of the customers. So even you can see x-axis is represent the credit score, and before to the below the 750. So that the most of the customer, even more than half or the 50% of the customers, their credit score is below the 750. Only the some few customers, their credit score is above the 750. Almost 50% of the bank customers, almost 50, or you can say 70% of the bank customers, their credit score is below the 750. Now here you can see everyone. So here we have information of the all the customers of here we have information of the age of the all the customers of the bank, and all the particular customers there. So all the particular customers of the bank, so their age is less than 35. Maximum customers of the bank, their age is less than 35. They're only the few oldest customers the bank has. So maybe the bank don't have a good services for the oldest customer. Then again, here we have the particular the tenure. Okay, so tenure we have a 0 year, 1 year, 2 year, 3, 4, 5, 6, 7. We have a tenure for that. And you can see there are around to the 400 customers. They are recently opened the bank account, or for them the tenure is less than 1 year. They're almost the 1,000 customers. For them, the tenure is 1, 2, 3, 4, 5, 6, 7, 8. Then again, here we have a next graph is bank balance. So bank has a two type of the customers. One customer, their bank balance is very, very less, and second type of the bank customer, their bank balance is very high. So you can see all the there are lots of the customer, their bank balance is near to the 0. There are also lots of the customer, their bank balance is in the range of the particular 20K to the 50K. Okay. So all the customer, their bank balances in the range of 50K to the 200K, most of the customer. And there are also some customer, their bank balance is very less or near to the 0. Then again, the next variable is number of the product. And as you can see, the more than 95% of the bank customers are using 1 and 2 product. Okay, only less than 5% of the customers are using a 3 and 4 product. Now we have a distributions of a salary of all 1,338 customers of the bank. and the salary is the distributions of the salary is almost same for the all 1,338 customers of the bank. So everyone, now we are performing this Uni Variate analysis on the continuous variable. And after this Uni Variate analysis, we have a lot of informations about data. We have informations like almost more than 75% of the bank customers, their credit score is less than 750. Most of the customers of the bank, they are defaulted, that they don't pay EMI dues or loans on the particular time. Or bank has a two type of the customers. One customer, their bank balance is zero or near to the zero, and second type of the customer, their bank balance is in the range of 20K to the 500K. Almost 70% of the bank customers has a credit card. Almost the 20% of the bank customers left the bank. Almost the 400 customers, for them the tenure is around to the 10-year. Almost the almost the particular 1,000 customers, for them the tenure period is 1, 2, 3, 4, 5, 6, 7, 8 years. Most of the customers of the bank, their age is less than a particular 30 or 38 or the 40. Bank has a few old age customers. Almost the particular 50% of the bank customers, almost the 50% of the bank customers not actively using a bank services. So now we have lots of informations about our data, right? So we'll continue this particular part and now perform bivariate analysis, everyone. So we'll perform the bivariate analysis, and during to the bivariate analysis, we check it like a relationship between the two different variables or dependency of one variables on other, or impact of one variables on by other. We'll check that particular part. So during a bivariate analysis, so everyone you can see, let me just use a df.head. So here we have information of the credit score, we have information of the geography, gender, age, tenure, balance, number of product or hash credit card, estimated salary, and particular existed. So we want to analyze that which type of the customers left bank so far and why the customers are closing their account, or which factor influencing such kind of a trend. We want to get answers of all these questions, business questions. So first we perform Uni Rate Analysis, and this approach will help you to analyze or to explore any data. In the bivariate analysis, as we discussed, we check impact of each variables on other. So here we have a particular main dependent variables, or actual tag is last column, which is represent the, or which is information of the customers, whether customers left bank or not. So we'll during to the bivariate analysis, we'll take one variable is existed and another variable is all the remaining variable, and take perform analysis one by one. Okay. So now let's take a particular continuous variable. So you see we have all the dependent variable is a categorical, and we have independent variables are categorical and continuous also. So now everyone, now let's check it the the histogram for all continuous variable like a credit score, age, bank balance, or number of product, such or the estimated salary. For them we'll check the histogram. So here everyone, so we know that A is a list of all continuous variable. So for I in A, SNS dot hist plot x equals to the I, data equals to the df. Sorry, we already performed the histogram, my bad. Now we want to perform the bivariate analysis. So during to the bivariate analysis, we check the impact of each variable on another. So let's take it, your dependent variable is a categorical. Okay. and your all the independent variable like a credit score. So impact of the credit score on the particular existed or the last column you want to analyze it. So here, whenever you have one categorical or one continuous, so we discuss we can use a box plot, you can use a swarm plot, you can use a line chart. Even we can also use the particular histogram and analyze the impact of each variables on the dependent variable, each features on the dependent variable. So here everyone you can just use the particular hist plot. And in the particular hist plot, here you can everyone you can just perform in such way. So here we are just selecting so I'll just analyze, let me just complete it. So everyone here you can see, so we are taking a particular all the values of the credit score, the customers of the all the customers who left the bank, and customers of, we are just taking a credit score of the all the customers who left the bank and customers of the credit score of all the customers who did not left the bank, and we are plotting on the same graph, same window, and perform interpretations on it. So let's take it here, and so here we have everyone you can see. Okay, you can just change color here. So we are just trying to change the color. Let me just check a final impact of it. I'll take it this one as a particular R. Okay, now this is substance perfect. Okay, sorry. So everyone, you can see now here we are just using this one categorical and one continuous variable and plotting performing such analysis here. So here we have a particular, we are just selecting all the continuous variable when the customers left the bank, and all the particular, the continuous variable information when the customers did not left the bank, and plotting on the same window and performing analysis on that. So here everyone, you can see we are just using the his plot because we have a continuous variable. So A is a list of all continuous variable. The first variable is a credit score. So we are selecting a information of the customers of the credit score, customers who left the bank, and plotting using a red color graph. And also the customers of the credit score of information, the customers who did not left the bank, and plotting using a black color. And now we have all this information here, everyone, you can see. We have information here, the credit score of the customers who left the bank and the credits of the customers who did not left the bank. Now let me save this diagram, then after we'll perform interpretation. Or let's do one thing. plt.save figure, and just you can specify the location of it. So let's save this all this diagram so that we can will download it and perform the interpretations. So everyone, you can see we have all this diagram here. Now let's interpret all this graph one by one. So the first, let's take it the credit score. Okay. So everyone, you can see this particular black color represent this black color graph represent the credit score of the customers, who did not left the bank, and this is represent the credit score of the customers who left bank. Okay. So all of you can see that as we discussed that almost 75% of the bank customer, almost 75% of the particular bank customers, their credit score is a less than 700 or 750, right? Then again, you can see that here we have a particular red color bar below the particular 400, and red color represent that all the customers who left the particular bank. This is the particular one, sorry, my bad, this is the 0. All the customers left a bank whose credit score is a less than 400, because you see the red one we are representing as a 1. So red one is the distributions of the credit score of the customers who left a bank, and all the customers left a bank was their credit score is a less than 400. And again, you can see everyone here very important patterns there is. So if you see when the credit score is in the range of 400 to the 850, you see the pattern of the customers who did not left bank or close their account. The pattern of the customers of the bank for the customers who did not left a bank, it is equal or same to the pattern of the customers who left the bank. So the pattern of the customers of the credit pattern of the credit score of the customers who left and the pattern of the credit score of the customers who did not left the bank, it is almost same in the range of 400 to the 850. But all the customers left bank, their credit score is less than 400, right? So this is the one outcome that we are performing or analysis we are performing of using a using data visualization approach. Now let's see here. We have a particular the age of the customers. We have distributions of age of the customer for the age for the customers who left and the customers who did not left the bank. So red color, as we discussed, is represent the distributions of age of the customers who left the bank. And as you can see, the frequency is very high after the 40. Means more oldest customers are closing their account, and still bank the loss of the customers of the banks, their age is who did not close their account, their age is in the range of 40 to the 35 or the 45. It means that bank don't have really good policy for the oldest customers or the customers who their age is greater than 40, and that's why the lots of the customers are closing their account. That as group of customers are closing their account. Now you can also take it another graph here that we have this one. This is something distributions of the bank balance of the customers who left and the bank balance of the customers who did not left the bank. So everyone, you can see there are some customers, the black one or red one represent the customers who left the bank, and the black one is represent the customers who did not left the bank, their bank balance distribution. And the customers who left the bank, so the customers who left the bank and the customers who did not left the bank, their distributions. So when the customer bank balance in the range of 50K to the 200, loss of the customers left the bank and the loss of the customers did not left the bank also. And here also, whenever the customer, their bank balance is in the range of 0 or near to the 0, some customers left the bank, but most of the customers did not left the bank. So we have here now the number of the product. And again, the red one is represent that the distributions of the customers who left the bank, and black one did not left the bank. So everyone, you can see all the customers left the bank who is using a 4 product. Almost the most of the customers are left the bank who is using a 3 or the 4 product. Only the few customers left the bank who is using 1 and the 2 product. Then again, we have here the distributions of estimated salary for the customers who left the bank and the customers who did not left the bank. It is almost same. So everyone, you can see now we have a distributions of tenure and the distributions of estimated salary for the customers who left and the customers who did not left, and it is almost same, right? So now let's perform the interpretation here, everyone. So we have all this graph as you can see, and let's perform the final interpretation. So the first graph is represent the distributions of the credit score for the customers who left the bank and the customers who did not left the bank. We have distributions of their credit score. And as you can see, all the customers left the bank when their credit score is less than 400, and the maximum customers did not, all the customers left the bank when their credit score is less than 400. Okay. And the pattern of the credit score is almost same in the range of 400 to the 800 for the customers who left and the customers who did not left bank. Then again, we have informations like distributions of age. The distributions of age for the customers who left and the customers who did not left, it's different. Most of the customers left bank, their age is greater than 35 or the 40. Means as we know, the bank has few oldest customers. Then again, the maximum customers are closing their account whose age is greater than 40 or 35. So we can say the bank really don't have good policy or the services for oldest customer, and that's why these the age group of the people or the customers of the banks are closing their account at very high rate. Then again, the tenure. Tenure is represented from how many year customer is a client of the bank, and we know that there are almost the 400 customers, almost the 400 customers who's using a client of the bank from the last less than 1 year, and there are around to the 500 customers or the 600 customers who is the client of the bank from the last 10 years, and almost the 1000 customers who is a particular client of the bank from the last 1 year, and all age, all the particular tenure. And here you can see the distributions of the tenure for the customers who left and the customers who did not left the bank. It's almost same, right? Then again, we have information of the bank balance. So bank balance. So here you can see everyone. So we have information of the bank balance or the distributions of bank balance of the customers who left and the customers who did not left bank. And the pattern is almost same for the customers, not exactly same, but almost same for the for the customers who left and the customers who did not left bank. Their bank balance, their pattern is only a little bit different, but most of the part is almost same. Then here you can see the customers who is using a 4 product or the 3 product, maximum customers left bank. And also some customers are left bank who is just using 1 or the 2 product. So here the distribution is a bit different. The distributions of estimated salary for the customers who left and the customers who did not left the bank, it's almost same. So everyone, after the performing this bivariate analysis, now we have lots of information about our data set. So again, we are using data visualization approach to perform such analysis. Here you can also use it whenever we have one categorical and continuous. Okay, you can also use the particular like here we are using a particular histogram. You can also use a box plot. So for I in A, SNS dot box plot x equals to the I, data equals to the F, x equals to the existed, y equals to the I, and then PLT dot so. So everyone, now we have a box plot and of the particular all the customers who left and the customers who did not left the bank. So everyone, you can see here first variable is exist. So x-axis we have existed, which contain the value like a 0 or 1. One is represent the customers, one is represent the particular the customers who left the bank, and 0 is represent the particular the customers who did not left the bank, and the y-axis represent the credit score. So you can see the 25 percentile value, 50 percentile value, and 75 percentile value, and length of the particular the box. It is almost same for the customers who left and the customers who did not left the bank. Only we have some few outliers for the customers who did not left the bank. We have left the bank, for them we have some outlier. It just represents that all the customers left the bank whose credit score is less than 400. Then again, we have the distributions of the age for the customers who left and the customers who did not left the bank. And as you can see, the 50 percentile and 75 percentile value, it's higher for the particular the customers who left the bank. Means more old age customer left the bank or closing their account. Then again, here we have a particular, again, the existed, and the y-axis is the tenure. And again, we have almost same for the 25, 50, and 75 percentile value. Right. And here you can see everyone for existed for the bank balance. So we have a 25, 50, and 75 percentile value is a bit different. As you can see, all the particular customers did not left the bank when their credit score, when their particular or around to the 2500 customers, their bank balance is 0 and they did not left the bank. And almost the particular, the 5000 customers, okay, 10,000 sorry, yeah, almost the 2500 customers, their bank balance is less than 10,000, but they did not left bank, or they left bank. Almost the 10,000 customers, their 2500 customers, their bank balance is less than 10,000, and they did not, they are particular left bank, right? And they're almost the 10,000 customers, their bank balance is 0 to the 10k, and they left bank. So here we have a little bit different patterns, and almost same pattern for the customers who is using a particular. So you can see everyone, we have a number of the product and we have a particular x-axis is the variable. Similar way, everyone, you can see we have estimated salary and the 25, 50, and 75 percentile value. You can compare it, and now we have informations here. So whenever you have one categorical and continuous, you can use histogram, you can use a box plot to extract information or to visualize or to represent your information in the form of the graph. So now we'll take it between the two different continuous variable. And as we discussed, whenever we have a two continuous variable, always use the particular frequency table. Okay. So now we'll see this particular between two different categorical variable. So whenever you have a two categorical variable, always use a frequency table or the cross tab. So now let's suppose that you want, we have a particular df dot head here, right? So there's some kind of a, so our actual label is also categorical, and then we have some categorical features also. Let's suppose the gender and existed, geography and existed, hash credit card and existed. So between them, how to analyze the relationship or dependency. So whenever we have a two categorical variable, always use the cross table. Let's understand through some example here, everyone. So here we'll take a two categorical variable out equals to, let's take it pd dot. So is the pandas function. So we are using pd is pandas. So cross tab, and over the first variable, you can take it, let's say a kind of gender, and another variable, take it like existed. And here you can specify margin equals to the true. Then print. We have the out here. So everyone, you can see here we have a cross tab between gender and existed, and we have columns like columns represent the existed, which is something contains 0 and 1. 1 is represent the frequency, like number of the customers who left the bank, and 0 represent the number of the customers who did not left the bank. Then again, gender x-axis like a row, and where we have a particular male and the female. So everyone, you can see the particular, the bank has a total 4543 female customer, and out of 1139 female customers left bank, and 3404 female customer did not left bank. Similarly, a total number of the male customer is 5457, and out of 898 male customer left bank, and 4559 customer male customer did not left bank. Total number of the customers who left bank is 2037, and total number of the customers who did not left bank is 7963. So what we'll do is, now we know that this 1139 represent that number of the female customers left bank, and 898 represent that total number of the male customers left bank, and 2037 represent that total number of the male customers left bank. So what will we do that is, we'll divide 1139 divided by the 4543, 898 divided by the 5447, or 2037 divided by the 10,000, and it will be written existing rate for male female customer. So everyone, you can see, if I'll just select the particular the one, so I just written the 1139 and 898, and if you just divide by the particular the out and all, so now we have existing rate for the female and existing rate for the male customer. Existing rate for the male and existing rate for the female customer. And as you can see, existing rate for the male customer is 0.16, and existing rate is for the female customer is 0.25. It means that more female customers are closing their account. Our existing rate is very high for the female customer, is around to the 0.25. Out of the 100, 25 the customers are closing their female customers are closing their account. Maybe the bank don't have a good policy or the services for the bank customers, and that's why they are closing their account at very high rate. Okay, so everyone, all of you can see that here we have information. Existing rate for the female is a churning rate, even you can say the female is very high, is 0.25. Means at very high rate, the female customers are closing their account, right? So it's very important information. So now here we are doing, if you have a two categorical variable, so we can also use a cross step, but the same information you can also visualize using two bar graph. So SNS dot bar plot, and here on the axis, so let's take it the for loop here, and for I in B is a list of all categorical variable. So SNS dot bar plot, x-axis, let's take the particular all variable, and the y-axis you can just define as existed and data equals to the dir, and then plt dot show. So here everyone, you can see now we have this particular report here, and you can see the existing rate for in Germany is very high as a compared to other two countries. The customer, so existing rate is very high in Germany. Maybe the bank services in the Germany is not good, that's why at very high rate, almost 0.35, very high rate, the customers are closing their accounts. Then again, here you can see, we know that only the 2,500 customers from the Germany, almost 50% of the bank customer from the France, but again, the existing rate is very high. Similar way, existing rate. So the one question here, if you want the get the cross step in the percentage, then how we can do it? So you can just multiply with the 100 here. So the 25 percentage existing rate for the, you know, the existing rate for the female is the 25 percentage. Existing rate for the male is around to the 16 percentage. Total churning rate or existing rate is a 20%. So existing rate is very high for the female. Out of the 125, you know, customers, female customers are the closing their account. And same information that we are doing to here also in the using a bar plot, but here we have a particular cross step in percentage as well, right? So everyone, you can see here. So existing rate is very high for the female customer, around to the 0.25, right? So again, you can see the existing rate is almost same for the customers with credit card and the customers without credit card. And we know that almost 70% of the bank customers has credit card and 30% of the bank customers don't have a credit card. But existing rate or the churning rate is same for for the customers with the credit card and the customers without credit card. And now here we have informations about active member, each active member. Okay, so one means yes active member, zero means so one means the particular the customer is one means a customer is active member, zero means customer is not active member. And you can see the existing rate is very high for the customer who is not actively using a bank services. So this is the between existed and existed, so you can just skip it. But here we have a particular existed and is active member. So churning rate is very high or existing rate is very high for the customer who is not active member of the bank. Right. So this is about analysis so far we perform here. Let me just recap it. So everyone, so we are just using this approach, like you can start with the univariate, bivariate, multivariate analysis and perform the analysis on this particular data using data visualization approach and extract all hidden information and the pattern. Now using this information, then finally you can design some analytic report. So here we discuss that whenever you have any data sets or if you want to perform data analysis, the first step is understand business problem. What is your end objective? It's very important to understand. Okay, what is your end objective? What is your data set, your business problem? Data understanding is very important. Let's suppose that there's some variable like a credit score, there's some variable like a salary, and you don't know what the salary means, so you won't be able to interpret graph. So here we are performing, then again, you can start with the univariate analysis, then bivariate analysis, then if required, then again, we can also perform multivariate analysis. So here we are just performing univariate analysis and the bivariate analysis. In the univariate analysis, we select all the variable one by one, use data visualization approach and perform analysis on that. On the particular bivariate analysis, we take two variables and we take a two variable and use a data visualization approach using a particular, we take a two variables and using a different types of the graph, we can check impact of the each attribute on the label, or we can also check a relationship or dependency between them. Or this is also help to extract hidden patterns or the informations present in data set. So the first we are performing univariate analysis. And if a variable is a continuous, so we are using histogram for it. Using the histogram, you can analyze the distributions of data. And while performing the histogram, we analyze that almost 75% of the bank customer, their credit score is less than 750. And we know the importance of the credit score. Credit scores represent the financial credibility of any person. If normally the credit score is, so always the credit score is in the range of 300 to the 800. If the 300 to the particular 900, if the credit score is near to the 900, so it means that persons pay their EMI dues loan on the time and maintain their account balance. If the persons don't pay their loan dues on time, the credit score value will be less than 750 or the particular 700. So here we analyze that almost 75% of the bank customer, their credit score is less than 750. And we also analyze that almost all customers left bank whose credit score is less than 400. And distributions and the patterns of the credit score, it's almost same in the range of distributions, or the pattern of the credit score is almost same in the range of the particular 350 to the 850, sorry, 400 to the 850. Then again, we also discuss about age. In the age, we analyze that most of the customers of the bank, they are the particular, their age is a less than particular 35. Okay. And bank has very few old age customers. And most of the particular the customers whose age is greater than 35, okay, they are closing their account. So existing rate, the closing rate is very high, or at very high rate, the customers are closing their account whose age is greater than 35 or the 40. Maybe the bank don't have a good policy for this age group of people. Then again, we use a particular some another variable like a particular tenure. Tenure represent the particular from how long a particular customer, or from how many year customer is a client of the bank, or customers has a bank account. And we analyze that almost the 400 customers, they are recently opened the bank account, or for them the tenure is less than 1 year. Almost 600 customers, for them the tenure is 10 year, and almost 1000 customers, for them tenure is 1 2 3 4 5 6 7 8 and 9 year. And existing rate is almost same for the customers, for them for the tenure is 1 year, 2 year, 3 year, 4 5 year, or 7 8 9 10 year. Then again, we also select this particular, we also perform analysis on the bank balance. And we analyze that here, the bank has a two type of the customers. One customers, their bank balance is zero or very near to the zero. And one customer, their bank balance is in the range of the 50K to the 200K. And existing rate is a bit different for the customers whose account balance is in the range of, the distributions of different for the bank balance for the customers who left and they did not left. Then again, we also perform analysis on number of the product, and we analyze that only less than 5% of the bank customers are using 3 and the 4 product. Most of the customers, or more than 95% of the bank customers, are using 1 or the 2 product of the bank. And all the customers left bank who is using a 4 product, or existing rate is very high for the customers who is using a 3 and 4 product, and the less for the customer who is using 1 and the 2. Then again, we also analyze about the estimated salary. So the distributions of the estimated salary for the customers who left and the customers who did not left is almost same. And yeah, and all the particular customer, their salary is in the range of 0 to the 200K. Then again, geography. 50% of the bank customers from the France, and 25% of the bank customer from the Germany and the Spain. And existing rate is very, very high in Germany. Then again, we also discuss about the particular gender. So for max 55% of the bank customers are the male, and 45% of the bank customers are the female, and existing rate is very high for the particular female customer. Has credit card. 75% of the bank, 70% of the bank customers has a credit card, but existing rate is almost same for the customers who with the credit card and without credit card. Is active member. Okay. Then again, is active member. So here we analyze that almost 50% of the bank customer, almost 50% of the bank customer not actively using a bank services, and existing rate is very high for the customer who is not active member of the bank. And almost the 20% of the bank customers left bank so far. So this is the complete analysis using data visualization approach and using univariate and bivariate analysis. So multivariate analysis, here on this variable, let me show you. I'll take it here. Okay, let's take it here. One variable. So multivariate analysis, when we have a particular more than two variables. So as of now, here we don't require multivariate analysis, but I can show you here. So let's suppose that scatter plot. Scatter plot, x-axis, I'll just take it here. Credit score, y-axis, you can take it like age. And in the scatter plot, we can also, in the Seaborn library, we can also take a three variable. So we are taking x variable as a particular credit score, y variable as a age. So let's take it here and plot the particular visualizations of plt.show. Let's see here. So here, everyone, we have a particular So here we have a scatter graph between the credit score and age, and in that we have particular credit score on the particular x-axis, and the y-axis is the particular age. And as you can see, there's a non-linear relationship between the credit score and age. As age is increasing, the credit score is not increasing. For most of the customer, when their credit score is less, lots of the customer, their age is a less also and even high also. When the customer's age is a particular, less, or the particular, there's a non-linear relationship between the credit score and the particular age, you can see. In the multivariate analysis, we generally take more than two variable and check a relationship between them. If there's some relationship present, we can analyze it. Okay, let me show you in some other data set where you can really interpret it. So I'll show you this particular multivariate analysis. But here, this is something we perform, bivariate analysis and univariate analysis, or we perform data analysis using data visualization approach on this data and extract all the hidden patterns or the informations from it. Now, based on this information, you can, you can design some analytic report and share with the managers, and they can use it to, they can compare those information with their policy and improve the, take it those information or extract the informations or find the useful informations or take it all the information while designing some new policy. So I'll show you the multivariate analysis here. Let me let me load one data set here. Okay, because here in this particular bank chunk modeling data set, we don't have a good patterns for the multivariate analysis here. So that's you won't relate it in real time. Let me just take another data here. So import pandas as a PD, import SNS library here. So I'll just take one data set here. So data equals to PD dot read underscore CSV. So here, everyone, you can see we have information of the 1,338 customers of one of the insurance company. Okay, and for some customer, their insurance charges is very high, and some customer insurance charges is very low. And we want to know that why the customer, which type of the customer the insurance charges is high, or for which type of the customer insurance charges is low. This is something and objective here. So when we are performing the analysis, so we can just plot the graph between age and the particular charges. We can check the relationship between them. So you see, if I take a particular X variable as a particular age and the Y variable as a charges, because both are continuous variable, so we can use the, here you can use the particular scatter graph to perform analysis on that. And you can see here, everyone, we have a particular linear relationship. Okay, here we have particular some linear relationship, or we have a particular some, you know, we have some linear patterns here. No, when we have a dependent variable, it categorical also, and even in the continuous also. So, okay, just let me check. Dependent variable is a categorical variable, right? And when we are trying to plot the for it, yes. So dependent variable is a last variable, is a categorical variable in this case. Okay, in that particular case, which is represent the last variable existed, 1 or the 0. Yes, and independent variables are all the remaining features. So here you can see we have a scatter graph between age and the charges, and as you can see, when age increasing, charges is also increasing, but into the 3 different range. Okay, there are some customer when their age increasing, charges is also increasing, but into the very low range scale, and there are also some customer when their age increasing, charges is also increasing into the very high scale. So in the multivariate analysis, you can take one more variable here using HUE function, and let's take it another variable as a smoker. So smoker is also present here. When we have a 2 continuous and 1 categorical, so we can also use a particular scatter graph. And you see, everyone, here we have, you can see x-axis represent the particular age, y-axis represent the charges, and here we have a blue color bubbles represent the customers who are the smoker, and yellow color represent the customer who are not smoker. And as you can see, as age increasing, charges is also increasing, but into the very small range for the customers who are not smoker. But the customers who are the smoker, for them, when age increasing, charges is also increasing into the very higher range. So you can see we are performing analysis by taking a more than 2 variables. So we are saying it's multivariate analysis. It's multivariate analysis because we are performing analysis on the more than 2 variable. Right. So last section here, let me just run the last topic. So the first, using such approach, you can perform the data analysis. So you see, everyone, we discussed that how to analyze any data using data visualization approach. And after this particular part, you can also design the final report. So this is the one sample report. The first in the slide just mention the table of content. Okay, what are the content table of the content here, about the problem statements, all this approach you can mention here, and then define the particular problem statement. So here we are performing, this report of the IMDb data sets, and first define the particular table of content, then what is the problem statement, what is your and objective, just define all this particular point here. Then again, now we are performing the univariate bivariate analysis. So you have all the report, save all the graph, and one by one just import it and perform interpretations and extract information. So what is the outcome of this graph? Okay, or what, just describe or interpret this particular graph, and also mention the outcome of it. So see, everyone here, so like there are the different graph and the outcome as well of it. So just mention here. In this way. Then finally, you can just define what is the end conclusion. So what all the information, all the particular outcome mentioned here, and all the conclusions, or summarize all the analysis. And then actionable insight. So what kind of the action that should, a particular company should take. You can also define this particular part. And your approach that to perform analysis also to mention here. So in this way, you can design some analytic report in that define the problem statement, in that whatever the analysis you are performing, you have all the graphs, so one by one import it, interpret all the graph, and also mention the outcome of it. Then again, after this particular part, summarize the entire analysis, all the information, actionable insight, mention it. Okay, and then after you can also mention your approach and conclusion. And in this way, we design the analytic report, And finally, we share this particular report with the manager. You don't need to share this particular coding part with them. We just, you don't need to share all this particular code. We don't share this particular part. Just download all this particular, save all this figure, design some PPT, or then in that just mention or interpret all the graph, and also mention the problem statement, your approach, all the outcome and conclusion. And then we share that particular report with the managers, and they use those analytic report while designing some new policies, or in order to understand the business problem, or to get answers of all the business question. So I hope it is fine for everyone. Any questions so far, please let me know.
Thank you so much, Ashish. I hope you've all loved this session on data visualization, and we've used Seaborn library to visualize charts, but we have also done some level of exploratory data analysis. So we've actually taken a look at data. We've seen how to analyze banking data, understand trends, multivariate, univariate, etc. So we've had a great start in our data science journey right now. So I really appreciate all of you. For all those who are on the free seat, I really appreciate that all of you have stayed along, for 14 full sessions. It's been 3 weeks, and I hope you've had a lot of value to gain out of this. So before you go, I want you to get a sneak peek into how machine learning works. And I'm going to show you a program that's generated by BlobCity's AutoML tool. So let me see if I can share my screen here. Ashish, you might have to stop sharing your screen. Yeah, thank you. So, okay, yes, here we go. Okay, so what you see here on the screen is essentially a program, and the source code is not humanly typed. This is actually computer generated code, 100% computer generated. And you can see these are your imports, and you might be seeing a lot more imports than you're used to seeing them. But we do use matplotlib, we do use Seaborn, NumPy, and pandas. These are like very common. The rest are related to what we do in machine learning, and you will learn these in the coming days, right? Now we've taken a stock market data. We've actually just taken, Tata Steel data. This is the stock price, and what we want to do is predict if the stock market will go up or down. Okay, so we want to do trading on the stock market. So we've taken input values, which is volume and RSI. So our intention is actually to find a correlation of volume and RSI to a decision. And the decision here is buy or sell or do nothing. So it's a classification problem wherein the things we want to classify is whether we buy something or we sell the stock, whether we buy the Tata Steel stock, we sell the Tata Steel stock, or we do nothing, which is just be, without having an open position. So that's the simple decision bit. Then if you go down, you can actually see there are some hyperparameters, and we will be learning about what these hyperparameters are in tomorrow's session when we begin with machine learning. And these parameters usually talk about the type of kernel you use. We have used an RBF kernel. You can use a linear kernel, and there are several different types of kernels. And you can also have C value, gamma value, and degree value, which is there. And we will cover more of this, but it's very simple stuff, right? So what you have here is split ratio of 0.2, which means that we have 20% of the data that we use for testing, rest of the data that we use for training. And you're obviously comfortable with this, which is pd.read CSV. We are just taking data from a CSV file, which is Tata Steel, actual data file. We want to, take that CSV file and we basically read it, right? And we can see how this file looks, and we have certain columns here, and we have certain decisions here based on whether you should buy, sell, or do nothing, right? And then we just did a feature selection, which is we want to select what features we want to use for our input and output, right? So we have features which are your X values and Y value, and in this case, our features are volume and RSI, which are two parameters we want to correlate. And my target is my decision, whether buy, sell, or do nothing. It's as simple as that. Now here we do some level of data pre-processing, and we have created some high-level functions, and these are provided by BlobCity actually. So you don't have to do much. Our AutoML generates these functions and gives them to you. So they'll do an automatic cleaning of data. It'll automatically do encoding of data. So what happens is when your data comes in labels, you need to convert it to numerical values, because all machine learning models take numerical data only. They don't actually accept data in string form. So your encoding of X values and encoding of Y values will be done by this, right? Then we do some amount. We basically run through all the columns, perform the corresponding encoding, right? Then we take unique values of Y, which is my target value is 1, 2, and 0, wherein 0 means sell, 1 means do nothing, and 2 means buy. Okay. And that's what it is. And then I've basically gone and split my data. So this is where my actual, so everything about this is just data preparation. And all you've done is prepare your data. This line is the first line where we actually begin with machine learning. And all we're doing is we are creating, we are splitting our data set into a training data set and a testing data set. So we will take the training data set, pass it on to the data science model for it to learn from that data. And then we will take a separate testing data set to measure the accuracy of your data science model. Okay. Now, this is the first line that we've actually written for our data science program, which is for the ML program, where we did a train and test split up. Then immediately we go into creating a model, and this is a support vector classifier, which is part of support vector machines. We're using an SVC model, and we have passed these kernel values, etc., with a random state of 123. All of these are auto-generated by AutoML. And actually, when you register for the course, we actually give you $100 in free AutoML credits. So you get almost 7,500 rupees worth of free credits for performing AutoML on BlobCity. And we have a session which covers on how do you do automatic machine learning as well. So you don't have to, all this code, everything you see here is computer generated. This was not humanly typed, right? Computer created this. And for you to understand this, this is the first line where we actually created a machine learning model. That this is the second line for machine learning model. This is the third line where we actually fit the model. This is where we actually training the model at the moment, on the data, which is I pass the X value, I've passed my known value, Y value, and I'm training the model. And then I can predict what is the accuracy of the model. So immediately I can actually go down and I can predict what my accuracy is. You can see that this model is 81.91% accurate. What does that mean? It means if you were to bet on the Tata Steel stock using this AI model, you would be 81% right, which means 81 of 100 trades. If you take 100 trades, 81 of your trades would go for you. The remaining would go against you, right? So then we do stuff like, which is a confusion matrix, etc., which is just for us to understand what's happening a little better. And we can plot something called as a confusion matrix. And we will look at these ML concepts tomorrow on what a confusion matrix is. It kind of tells us how confused the model really is, right? Based on the training and then the forecasting. And you can actually plot even the decision regions to just get a sense of how it's viewed. And you can also plot the classifier accuracy. We can actually get an accuracy report of the classification. But what's interesting is the entire machine learning program was just this. So we took this data. This is the first line where you did a train and test split. This is the second line where you actually define your machine learning model. This is the third line where you actually performed the training. And then this is the fourth line where you actually did a prediction using your model. So you actually predicted data now using the model. So it is just 4 lines of code. And trust me when I say this, no matter what type of machine learning you do, it will just be these many lines of code. Instead of SVC, you can use SVR, you can use decision trees, you can use regressions, you can use random forest, you can even use neural networks if you have to, right? So there are various different types of options. So Lakshman, yes, SVC is supervised learning. You can also use unsupervised learning. And there are various types of functions that are there. And it is as simple as this. So when we teach you machine learning, we're not actually going to teach you programming. Everything that you had to program is already done. Machine learning code will pretty much write itself if you use any AutoML framework. And all you have to do is understand the fundamental basics of when to use what model and how each and every model works, right? And that's what we teach you as part of the course. So I wanted to give you this quick overview. So I really thank you so much for being a part of this training and getting a quick overview of how machine learning actually works, right? So let's go on with proceeding further on what we do in the sessions, right? So first of all, thank you very much for attending this course. And as we move forward onto the trainings, we can begin machine learning from tomorrow. So for all those of you who have already grabbed our offer, I really appreciate you grabbing the offer. I thank you very much for being a part of this course and grabbing this offer as we have moved on. And if you've not yet grabbed the offer, you have till 5 p.m. India time to grab your offer. So go get your seat booked. It's only till 5 p.m. today, and get your seat upgraded to becoming a data scientist. We will teach you everything with machine learning that you saw right now. We will teach you this as part of the entire course on data science. So thank you once again for being a part of the training, and do not forget to grab your seat. If you have any questions, do give us a call. I have one last request for all of you. And before we go, one important announcement. So that there is an email that you would have received to receive your completion certificate. This is applicable for all the people who are enrolled into the Python for Data Science training course. So all of you who are enrolled for the Python for Data Science training, you can receive your course completion certificate. Please fill the form that you would have received in the email. Now, just one last request before you go. Please do go ahead, proceed and register yourself. So please do go ahead and write us a review on Google. We would really appreciate that. We have been having some challenges. Our competition does not actually like the fact that we offer these free trainings on YouTube, etc. So we've had a lot of fake reviews that keep coming in. You all have been attending our sessions. We would really appreciate if you write us an honest review on Google. You're our true customers. You've seen us from the beginning. You're seeing us for the last 4 weeks. We would really appreciate if you give us a feedback. So I really hope all of you can write us a Google review. The link is shared on chat, and we would really appreciate it. We really love taking these sessions for you. And last but not the least, before you go, do not forget to subscribe onto the YouTube channel. So when we launch the next sessions, when we have new modules released for you, you can actually have access to them. You will get notified of them. So subscribe and please hit that bell icon so that you receive notifications for any new modules we release out there. So thank you once again. It's been a wonderful journey working with all of you. For all those who have upgraded your seats, congratulations. You're already booked. We're going to see you again tomorrow. It won't be on YouTube. It will be on Zoom. These videos that you have on YouTube will be live on the playlist for the end of the month. So if you need to watch them again, please watch them till the end of the month. Anyone who is upgraded has lifetime access to recordings of these videos via Zoom. So there's a feedback form also, which is shared above in the chat. Please do submit your feedback. We would always like to improvise on the course. And if you have any questions, join us on Slack. So this is not the last that we're communicating. Through cloud.blobcity.com, you have the Slack icon right on top. Just click the Slack icon, join the Slack group. You can connect with your peer learners. You can connect with everyone else that was part of the training. You can also connect with me. You can connect with the trainers. Just send me a direct message if you have to chat about any single thing. So we're still here. We're not going away. We'll still be in touch. And for all our paid members, you're going to be here for the next 2 months. So like it or not, next 2 months, you're going to see our faces. So thank you once again, Ashish, for the wonderful session. And we'll continue tomorrow onto machine learning and begin our journey in machine learning. And I really hope all of you do grab the seat. You've been here. You've done a lot of effort in learning Python. Machine learning, as I just showed you, is really simple. So I do hope all of you get a chance to grab the seat. All of you get a chance to become a data scientist. And all purchases comes with a 30 days money back guarantee. So you have nothing to worry. You don't like it, you can request for a refund within 30 days of that start, and you're good to go. So thank you once again, and have a lovely evening. And for several of you, we'll be seeing you again tomorrow, 11 a.m. You will receive an email tomorrow morning with the session dial and details. So bye-bye, have a great time. And please do leave a review for us on Google. We would really, really appreciate that. Leave an honest review, whatever you feel. We would really appreciate that. Thank you so much and have a nice day, everyone.